Hi, children. You're welcome to another wonderful week and another awesome class. I'm sure you had a wonderful weekend, and I want to believe that you did so much and so well in the last continuous assessment we conducted. I'll be sending your responses and your results to you, your mail, and you'll see what you have done and how you have performed. Please keep it up and try to do better as the class proceeds. Today in basic science and technology science class, I'll be teaching you basic electricity. Basic electricity. Don't forget that sometimes in our previous classes, I've told you about energy and I told you the types of energy that we have, different forms and kinds of energy, and how you can actually identify them around the house. And I told you about electrical energy. Good. Electrical energy, from that electrical energy, we have electricity, and that's what brings us to today's topic, basic electricity. You agree with me that a lot of things in the house uses electricity. Now, what is that electricity we are talking about? In today's class, I'll be telling you about electricity, and then the class will be divided into two parts. I'll tell you the remaining part of the topic in the next class. I am Mrs. Olainka, and I'm so excited to have you on this wonderful learning platform. Don't forget, the topic is basic electricity. Basic electricity. You can see electricity, the flow of electricity there. Okay. Now, at the end of the class, I expect you to be able to tell me what electricity is all about. What is electricity? Explain electrical circuit, and then list the types of circuits. And this is the big question of the day. What is electricity? What is electricity? You want to tell me the answer? Anybody have an idea? Electricity. Okay, let me help you out. Electricity is a flow of electrons around a circuit. What I say? Electricity is the flow of electrons around a circuit. You can see the flow of electrons, and it's actually going round. The flow is going round. Electrons are flowing. You can see the cell and the lamp. That is the flow of electrons moving around a circuit. Now I'll be telling you what a circuit is. Don't forget I told you before that this class will be in two parts. I'll tell you about electricity and circuits today, and in the next class I'll tell you about resistors and conductors, our cells and batteries, and all whatnot. And then we have a project we will need to do on this class, this electricity class. Okay, now let's go to electrical circuits. Talking about circuits, complete path of electron flow. A circuit is the complete path of electron flow. A circuit is a path that an electric current travels on. A path that an electric current travels on. You can see the switch, you can see the load, you can see the conductor, you can see the energy source going back to the switch again, and it keeps the flow moving. So we have the energy source, the conductor, the load, and the switch comprised of the circuit. So this is circuit. And don't forget that electrons flow from negative to positive, from negative to positive. That's how electrons flow, from negative to positive. So a circuit is a path that an electric current travels on. Okay, now I will be telling you about short circuits and open and closed circuits. I'll tell you about open and closed circuits. Now let me tell you something about short circuits first. An accidental low resistance connection between 2 points on a circuit. That is what we call short circuit. An accidental low resistance connection between 2 points on a circuit, and it causes excess electron flow. When this happens, when there's a short circuit, it causes excess electron flow. And when this happens, it can be very dangerous. An example is when a car knocked down a telephone line. That's when a telephone line is knocked down by a car. Can you see? It can be very, very dangerous. That occurs when there's a short circuit causing excess electron flow. Now, let me tell you about open and closed circuits. Open and closed circuits. Now, when a circuit is said to be closed, this is when electricity flow from an energy source, that's the battery or any other energy source, to the desired endpoint and then back to the source to start it over again, back to the source of the circuit. It's called a closed circuit then. When electricity flows from an energy source to the desired endpoint, and then back to the source again, and then continues the same process, it is called a closed circuit. You can see the picture of a closed circuit here. Can you see? It goes around and go back to the bulb. And it goes again, it keeps going, and it keeps going to the endpoint. To the endpoint, that's the closed circuit. Then it is said to be a complete path for current to flow. It has a complete path. When you talk about the closed circuit, it has a complete path for current to flow. But when you talk about an open circuit doesn't have a complete path for current to flow. It means it is not functional. An open circuit is not functional. It's more or less a short circuit. It's more or less what? A short circuit. An open circuit is not functional. That's an example. You can see the bulb is not on. Why? Because it is not functional. I will show you more example. I will explain better for you using a pictorial illustration. Looking at this picture, it says when electricity is able to flow freely through a circuit, we say it is closed circuit. When electricity is able to flow freely through a circuit, we say it is a closed circuit. When there's a free flow of electricity, you can see in the picture we have here. But when it is not allowed to flow freely, when electricity is not allowed to flow freely, it's an incomplete circuit, and we call it open circuit. So open circuit is an incomplete circuit. Is a what? Incomplete circuit. Because electricity is not allowed to flow freely. It's not allowed to do what? To flow freely. So it's called an open circuit. I'll show you another picture for you to actually understand what I am trying to say when it comes to open and closed circuits. Look at this picture again. We have a closed circuit here and open circuit. What can you really notice from this picture I have here? What can you notice? We have the battery, the cell, we have the bulb. But here as well, we have the battery, we have the bulb. But something is actually missing here. The bulb is on here. Why the bulb is not on here? Okay, who can tell me why the bulb is not on here? Because there's no connectivity here. That's why we call it incomplete circuit. Something is actually not making it to connect here. And then because of that, we call it an open circuit. Why this one is a closed circuit? So there's a free flow, and it's going round, and it's going around from the energy source, back to the end point, goes again to the energy source, back to the end point. But this one, it cannot connect to the end point, so there's no lights coming out from the end point. So you can see the difference between open circuit and a closed circuit. An open circuit is an incomplete circuit, while this is a complete circuit. Now let's talk more about circuits now. We have simple circuit, series circuits, and parallel circuits. Now let me quickly go to simple circuits. A simple circuit contains three components necessary to have a functioning electric circuit. And the three components are a source of voltage, a conductive part, and a resistor. I'll say that again. A source of voltage, a conductive part, and a resistor. Okay. Now, let me show you the picture of a simple circuit. Picture of a simple circuit. Okay, can you see the picture of a simple circuit there? Okay. We have the three parts I just mentioned for you in the previous slide. Can you see it? Source of voltage, a conductive part, and a resistor. Okay, now let's go to series circuit. Going to series circuit, it says the series circuit is a circuit in which resistors are arranged in a chain so that the current has only one path to take. Only one path to take. The current is the same through each resistor. You can see the current has only one path to take and it's going around the resistors. The current is the same through each resistor, and then they are arranged in a chain. You can see that they are arranged in a chain. You can see it there. And then the resistors are in a chain, and the current has only one path to take and is taking it. You can see the current is taking a path and is going through each resistor. Now let's go to the last one, which is a parallel circuit. I want you to note that houses are wired with parallel circuits. Any house you see around, we use parallel circuit to wire them. Now, parallel circuit contains two or more branches for current to move through. We have two or more branches for current to move through. The current can flow through both or either of the branches. You can see we have two or more branches for current to move through, and then it's a bulb, this is a bulb, and there's a conductor, and there's a battery, and then the current can move through either of them or both of the branches. That's a parallel circuit. Now we have come to the end of the topic that says basic electricity, and I'm sure that you have been able to be able to see what electricity is all about, what circuit is all about, and some different kinds of circuits that we have. So let's go to the question aspect of the class. Let's see what you have been able to learn. Who can tell me what is electricity? Anybody? Okay, is a flow of what? Electrons. Those electrons are flowing around what? A circuit. Good. Now I told you that electrons flow from what to what? Electrons flow from what to what? Negative to positive. Electrons flows from negative to positive. Good, don't forget that. Then let's go to quick circuit very fast. Okay, who can tell me what's a circuit? A circuit is what? Is a path that an electric current travels on. Is a path. Is a path. Now let's quickly go to the types of electrical circuits. I told you short circuits. I told you open circuits. I told you closed circuits. And I told you about simple circuit, series circuit, and a parallel circuit. Very good. Now I told you that parallel circuit is the one that houses are wired with. That is very, very good. Thank you for listening to the class. I'm sure you have been able to learn one or two things in today's class, and when you see the topic, or when you come across electricity, you'll be able to express yourself and say one or two things about electricity. Like I told you, I'll still be telling you more about this topic in another class. That is the second part of the topic. So I want you to study more on electricity before that time comes up. I'll be sending you a class activity tomorrow. So take care of yourself and be a good boy and a good girl.